Welcome to Part 6 in the Understanding Alarm Trip series from More Industries. In Part 5, we explored how key relay settings like failsafe and non-failsafe behavior, deadband, latching functions, contact ratings, and time delays can dramatically affect alarm performance and reliability. These settings ensure your alarms don't just react, they respond with purpose and precision. In this video, we'll dive into how the SPA2IS alarm trip can be used within hazardous settings when intrinsic safety is the method of protection utilized. Unlike many alarm trips, the SPA2IS is an associated apparatus that can simplify your installation. Traditionally intrinsically safe setups require separate barriers that add cost, complexity, and grounding challenges. But with an associated apparatus that integrates the barrier into the alarm trip itself, you can reduce wiring, potentially eliminate the need for clean grounding, and cut installation and maintenance costs without compromising safety. Intrinsically safe, or IS systems, are designed to prevent ignition in hazardous environments by limiting the energy that reaches the field device. To do this, IS installations require a separate barrier or associated apparatus between the field equipment and the control room. Even under fault conditions, these interfaces ensure that the voltage, current, power, inductance, and capacitance levels are low enough to eliminate the risk of sparks or heat that could ignite an explosive atmosphere. Zener Diode barriers are simple, passive devices made up of Zener diodes, resistors, and fuses. They work by limiting the voltage, current, power, inductance, and capacitance available to equipment in hazardous areas. While they're cost-effective and straightforward, they require a dedicated low impedance and noise-free earth ground. These IS grounding systems can often be susceptible to stray electrical interference and noise from other plant equipment, which could lead to measurement circuit errors. Isolated barriers are active devices that provide galvanic isolation, removing the need for a dedicated earth ground. This improves noise immunity compared to passive barriers. However, they require auxiliary power and are more expensive. Beyond the higher upfront cost, installation and ongoing maintenance can add complexity and additional expense. Using an associated apparatus, such as the SPA2IS alarm trip, can significantly reduce the cost and complexity of intrinsically safe alarming installations. These devices integrate the barrier directly into the alarm trip, eliminating the need for a separate IS barrier, additional cabinet space, clean grounding, auxiliary power supplies, or custom backplanes. Installed in the safe area or control room, the associated apparatus streamlines hazardous area alarming while maintaining safety compliance and reducing the total cost of ownership. In this video, we broke down the basics of how Zener and isolated barriers are used within intrinsically safe systems to manage energy levels between safe and hazardous areas. When alarming requirements are needed, we outlined how using an associated apparatus like the SPA2IS intrinsically safe alarm trip can simplify hazardous installations, cut costs, and reduce complexity, all without compromising safety when it matters most.